let's examine an LP blending problem. And it is the following. So AgriPro is a company that sells agricultural products, and they serve mix or feed mix to farmers. And the blend of the mix depends on the animals that need to be fed, the conditions, the weather, the pasture conditions, etc., etc. So they sell bulk amounts of the 4 types, and they can mix them together depending on what a farmer's request is. So let's take the following problem. Okay, let's say a farmer places an order and they're going to make a certain number of pounds of feed. There's going to be a certain amount of each pounds of feed 1, feed 2, feed 3, and feed 4 in the blend that AgriPro is going to make for the farmer. Okay, so our variables are going to be x1, x2, x3, and x4, where they are the number of pounds of the 4 different types of feeds that go into the specific blend for that farmer. Okay, and AgriPro's objective is to meet all the farmers' demands and to minimize the cost it takes them to make that feed that satisfies all of the requirements of the farmer and his livestock. Okay, so for cost, we're going to minimize our cost per feed type. So if we put x1 pounds of feed 1 in this mix, it's going to be, again, 25% or 25 cents per pound times the number of pounds of x1, and so on and so forth for the different feeds and their cost per pound times their number of pounds. Add all of those together and we get the total cost for producing this feed. Okay, the constraints. First of all, AgriPro has just received an order for 8,000 pounds of feed for a chicken farmer. Constraints. We know that we need a total of 8,000 pounds, so the total weight between all 4 types of feeds blended together, the total weight needs to total to 8,000 pounds. Okay, now the farmer wants this feed to contain at least 20% corn. So let's look here at our corn percentages within the feeds. So here's what we're going to get. If we have 30% corn in feed 1, then the amount of corn within our blend is going to be 30% times x1 being the number of pounds of feed 1 that we include. And then so on and so forth. So again, take your percentage of corn in each feed times the number of pounds of that feed included in your blend, and that gives you your total amount of corn. Now, it's given as a percentage as 20%. We take 20% of that 8,000 pounds, and that'll give us 1,600 pounds of corn that we need in our mix. Carrying on here, the farmer wants 15% grain. So same idea, let's look at those percentages of grains and go through our grain equation here. So here we are, 10% x1, 30% x2, 15% x3, and so on and so forth. And again, 15% grain out of the 8,000 pounds gives 1,200 pounds of grain required. And finally, 15% minerals. So looking at our table here, minerals are the same within each of the feeds except for feed 4 at 30%. So we do the following: 20% of x1, 20% of x2, 20x3, and 30% of x4. And then that has to total up to, 15% of the 8,000 pounds, giving us 1,200 pounds of minerals required. So that is our LP problem. We have our constraints, we have our objective function, which is to minimize our total cost, and our variables are the number of pounds of each of the feeds required. In a follow-up video, we're going to solve this problem in Excel. Okay, thanks for watching.